Okay, I'm going to solve this differential equation for you guys. As you can see, we are talking about second-order linear differential equation with constant coefficients. And you see that the right-hand side is not equal to 0, so this is a non-homogeneous situation. And we will not be using Wolfram alpha in this video. We will just go ahead and do it all the way. And you know the deal. We have to have the 3 steps, right? So let me put it down right here. First, we are going to find the YH. That means I have to look at this, y double prime minus 3y prime plus 2y to be 0, like this, and then solve that. So to solve this, we change this into r squared, and this is minus 3r, and this is plus 2, no r, this is equal to 0. Factor time, right? This is going to be r minus 1 times r minus 2 equal to 0, and you know r will be 1 and 2. From here, you know YH is going to be C1 e to the 1t, so let me just put down t, and then plus C2 e to the 2t. So here we have the YH. And now, here we are going to be using the method of undeterminate coefficient to find YP for the particular solution. So that's the step 2. So we are going to find YP right here. Well, YP depends on what kind of formula that we have on the right-hand side. And let me just put this down right here for you guys. First of all, remember, whenever you have sine, in this case it's sine t, we must have cosine t to help us out as well. So based on this sine t, I will just go ahead and put down sine t and cosine t, right? And this is being multiplied with e to the t, so right here I will have to multiply this by e to the t. Likewise here, e to the t, okay? So this is pretty much a building block for this particular solution. But I don't know the coefficients though, so I'm going to put down a right here and b right here, and then I'm going to add them up. So you know the deal. We take this and differentiate twice, and then plug in the second derivative and then first derivative and also the original into the differential equation, and then match the coefficients, and then find out what a and b are, right? And another remark before we do that, you see, yes, here we have e to the t, and yes, here we have e to the t as well, but this is just a constant multiple with e to the t. Right here, we have a times e to the t, and this is also being multiplied by sine t. In another word, this and that, they are not a constant multiple of each other. This and that are linearly independent, so we don't have to multiply by any extra t right here, which is a great news, isn't it? Anyways, derivative in action. Yp prime, and let me just put this down like this. I will look at this as my first function, and then this is my second function. And likewise, for the second term, this is my first, and that's my second. You know we have to do the product rule, right? Anyways, right here, I'm going to first keep my first function, which is a e to the t, and the derivative of sine is cosine t. And then we add it with we keep the second function, which is sine t, so let me put it down right here, okay? And we multiply by the derivative of a e to the t, which is just a e to the t, okay? And then next, we are going to be using a product rule right here as well. So I will put down, well, let me just put down the first function right here, which is b e to the t. And I will multiply by the derivative second. Derivative of cosine t is negative sine t. Okay, so we have the subtraction right here. And we add the second function, which is cosine t, and multiply by the derivative first. Derivative b e to the t is just exactly b e to the t, and that's such a beauty. Anyways, this is what we have. And if you would like, you can kind of combine the constants for the a and b. Maybe we should do that because right here, we have 4 terms already. And you know, this is multiplying, right? They are multiplying, so 2 functions. If you want to just look at the expression like this as how it is, and then do the derivative, you know, you have to use the product rule 4 times, and then you end up with a really long expression for the second derivative. So seriously, we should just collect some terms before we do the next derivative. This is still my first derivative, okay? So what I would like to do is, let me collect all the terms that has e to the t times sine t. So I'm talking about this one, right? This is a term that has e to the t sine t. And likewise, we can also combine it with this. Well, I'm just going to put down the function part right here, e to the t sine t, and the coefficient is a minus b, right? So let me just put it down like this, a minus b, like that. Cool. And then you see this and that can be combined as well. I will be adding them together. The coefficient is a, and the coefficient here is b, so it's a plus b. And then I will put down e to the t right here times cosine t, like this. Okay. To do the next derivative, once again, we are going to use the product rule. And now, you know a minus b is just a number. Do not put that down as like another constant. We must have a and b together like this, okay? We have to work with a and b. I'm going to just pair up a minus b times e to the t as the first function, and sine t will be my second. Likewise, I'll do the same right here. And this is just a dot for multiplication. Here we go. I'm going to keep the first function. Namely, I'll put down a minus b times e to the t. This is technically my first function. And then I will differentiate the second function, which is going to be cosine t. And I will keep the second function, which is sine t. And then I will differentiate the first. The good thing right here is that the derivative of the first is just that, because it's the constant multiple of e to the t. So it will still be a minus b e to the t, like this, okay? And then we'll do the same thing right here. I'm going to first keep the first function, so I will write down a plus b e to the t, okay? And we'll differentiate cosine, which is going to give me negative sine t, like that. And I will keep the second function, so I'll put it down right here, cosine t, and we'll differentiate this, which is still that, right? So we'll have a plus b e to the t. Just like that, that's the second derivative. And can we combine terms? Yes, we can, right? yp double prime. This is going to be, let's work with the et sine t first, which is once again in the middle, like this, and that, right? So allow me to just put down right here e to the t sine t first, and then I will figure out the coefficient right in the front. Okay, so do it carefully. This is positive a times positive times negative b, right? So this is right here, it's going to be a minus b. Okay, this is a minus b, like that. But when you distribute the negative in here, this is going to give you negative a and then negative b, right? So in other words, you see this a and that a will cancel, and then negative b will be negative 2b, and that's the coefficient in front of this term for the second derivative. And we do the same thing for e to the t cosine t. So let me just open the parentheses for the coefficients in a minute, and we will have e to the t cosine t, like that. So right here, this is just a minus b, nothing special. And right here, this is also a plus b, nothing special. But you see, minus b plus b cancel, and we just have a plus a, which right here, this is 2a. Okay? So in fact, the second derivative is actually better than the first derivative, isn't it? Anyways, here we go. We will plug in everything into the original. All right? So now, I'm just going to draw an arrow like this. So plugging yp. For the second derivative, I will just do that, right? I will put this down in blue. So this is going to be negative 2b times that. So let me just write down negative 2b e to the t sine t, and then we add it with 2a e to the t cosine t. This right here is for the second derivative, right? And we will, let me just write down the next line. So minus 3 times the first derivative, which is this right here. Okay, it's this right here. And I will just have to write it down for you guys right here. This is going to be a minus b, and we have the et sine t, and then we have the plus a plus b, And we have the et cosine t like this. Like that, right? And then this is for the second term, like that. And we have to add 2 times y, which is, we have to plug in yp. So it's 2 times that, which is a e t sine t plus b e t cosine t, like this. Okay? All of this shall be equal to e to the t sine t. Okay, now on the left hand side, you know you can collect enough terms so that you have something times e to the t sine t, and likewise something e to the t cosine t, and that's what we have to do right here. So this right here is what we have to do, and let me just set out first. Let's look for all the terms that has e to the t. Let's put down sine t first, right? I'm not sure what's in the front yet, and then we'll add it with something, and we have e to the t cosine t, and this should give us this e to the t sine t. Okay, and now we'll figure out what should go into the parentheses in red. So let's look for all the terms that has et sine t. First of all, I'm looking at this, right? This right here has et sine t, and this right here also has et sine t, but then be sure you see we have a times negative, a minus b like this, but we have a negative 3 in front. So be sure you take negative 3, distribute negative 3 times a, this is negative 3a, negative 3 times negative b is plus 3b, okay? So I'm looking at this term now. And lastly, we have this right here as well, and we have to multiply this by 2. So I'm just looking at the coefficient, so that's just 2a. All right, so now let's see what do we get. Let's collect the a first. 2a right here, minus 3a, so that's going to be negative a, right? 2a minus 3a is negative a. And then 3b minus 2b, this is going to be plus b. So that's what we have, okay? And now we'll be looking for the et cosine t term, which is this. First, I have the 2a right here. Let me just make it stand out a little bit more. And then next, you have to be careful. This is the term that we're looking at. We have a plus b, but we still have this negative 3 in the front. Take this negative 3, put it here, and then distribute. So you are talking about negative 3a, and then distribute it, you get negative 3b, like this. Once again, you have this negative 3, put it here, because you have to multiply in. And then this is another parentheses, so you have to distribute right here, and you get that, okay? At the end, you have 2 times this, which is 2b, like that. So we're looking at this terms now. Okay, let's do the a first. We have 2a minus 3a, which is negative a again. And then this and that together, negative 3b plus 2b is negative b, like that, isn't it? So this is very exciting, because now you see this right here, this is the coefficient for e to the t sine t. That must match with 1, because the coefficient right here is 1. Okay? So what you're saying is that you must have negative a plus b equals to 1. And this is the coefficient for et cosine t, but we don't have any right here. That means it's 0. So I will put down negative a minus b equals to 0. All right? And you can just go ahead and do this real quick. You see, you can just combine them. You get negative 2a. It's equal to 1, right? And let me just write down my 2 better. This is a negative 2a is equal to 1. So in other words, a is equal to negative 1/2. Plugging negative 1/2 into maybe this one, so we are talking about negative 1/2 for the a, minus b, I don't know yet, it's equal to 0. I'm going to move the b to the other side, so you see this is going to be b right here. Negative becomes positive, so you're talking about b is equal to positive 1/2. Oh my goodness, we are done with this, right? And you see, I didn't even use a calculator, so you guys can do this too. Anyways, this is going to tell you yp. Well, I should still put this down in blue for the yp, right? Okay, I will. Let me just put it down here, yp, okay? Yp is going to be a, we found it, which is -1/2. So let me just put it down right here. And then this is with e to the t sine t, okay? And then b right here is +1/2. So we will just put down +1/2 and then e to the t cosine t. And once again, here is my yp. And we got our yh right here earlier. Okay? So at the end, y, this is the step 3. So let me just put it down right here. This is my step 3. Remember y, which is the final answer for the very original. This is equal to, by the superposition principle, yh plus yp, right? So in other words, I'm just going to write it down right here. Y is equal to ce to the t plus c2 e to the 2t, and then I will have that, which is -1/2 e to the t sine t, and then plus 1/2 e to the t cosine t. And ladies and gentlemen, here is the final answer. Don't you feel so accomplished? That's it.